When waiting on a plane, the diver accumulates gravitational potential energy. The gravitational potential energy accumulated by the diver depends on the height that the diver decides to drop down from and the mass of the diver. The gravitational potential energy stored in the diver is directly proportional to the mass of the diver and the height the diver is diving from.
The physics behind the skydiver's diving process. Immediately upon leaving the aircraft, the skydiver accelerates downwards due to force of gravity. There is no air resistance acting in the upwards direction, and there is a resultant force acting downwards. The skydiver accelerates towards the ground. As the skydiver gains speed, their weight stays the same, but the air resistance increases. There is still a resultant force acting downwards, but this gradually decreases. Eventually, the net force on the skydiver is balanced by the air resistance and gravity. There is no resultant force, and the skydiver reaches terminal velocity. Finally, during the freefall, a skydiver can perform a variety of acrobatic maneuvers such as spinning, moving forward, moving backward, just by changing the shape of his body to catch the wind in a certain way. By doing this, he's essentially changing the direction of the drag force acting on his body. How does one increase their speed in midair? This is directly related to Newton's second law, which states the total force acting on the diver is the result product of the mass and the acceleration of the diver. So to increase speed, one will need to escape terminal velocity by accelerating faster, which is dependent on the total force and the mass of the diver. While mass cannot increase or decrease, we can increase the total force on the diver. Since mass does not change, then gravity doesn't either on the diver. Therefore, to increase the total force, air resistance has to be decreased, causing the forces to be unbalanced, resulting in acceleration and the diver escaping terminal velocity. To decrease air resistance, the amount of surface area of the diver that is facing the direction flow would need to decrease. This can be done when the diver brings their hands and feet together, touching their body, finally facing the ground and positioning their body vertically somewhere around 90-degree angle, depending on how much speed to increase. Formulas to calculate gravity and air resistance are as follows. To find the gravitational force, one will need to multiply the g constant and the mass of the diver. While to find the air resistance, one will need to multiply 0.5, the drag coefficient, density of the air, the surface area of the diver that is facing the direction flow, and speed squared. When the skydiver jumped from the plane, he had a gravitational potential energy, while his kinetic energy and thermal energy was zero. The skydiver's potential energy decreases as their altitude decreases. The kinetic energy increases as the speed increases. The thermal energy of the skydiver increases as there is friction between the skydiver and the air particles. No energy is destroyed or created during this process. As the gravitational potential energy decreases, the thermal and kinetic energies increase due to the law of conservation of energy.
When the diver deploys the parachute, the diver will experience a sudden upwards drag force. This is due to a large amount of air molecules colliding with the large surface area of the parachute. This large drag force in the upwards direction results in a net force in the upwards direction, acting on the object. The downwards force stays the same throughout this. This net force in the upward direction does not necessarily mean that the diver will start moving upwards. It means that the diver will slow down in its extremely rapid descent. The diver decelerates. We may have seen in movies prior to this that on deploying the parachute, the skydiver travels upwards for a short amount of time. You'd be surprised to know that that is not the case. It is the deceleration of the diver and the continuous acceleration of the cameraman that leads to the viewer thinking this. After some time, the drag force will become equal to the weight of the diver, reaching a second lower terminal velocity. Drag force caused by the parachute depends on several factors, such as the shape of the parachute, the size and weight of the parachutist, and the speed at which the parachute is falling. The larger the parachute, the larger the drag force. Air resistance will act with a greater force on the smaller and lighter objects, helping them remain in air longer. A decrease in velocity due to drag will lead to a decrease in kinetic energy. The question arises, where does the energy go when the speed of the diver decreases? The answer is quite simple. The speed is decreased by the air resistance. Therefore, energy is lost as kinetic energy is transformed into sound and thermal energy.
Physics behind the skydiver's landing process. To land safely, the diver, after releasing his parachute, would need to have a relatively low speed of maybe 5 to 6 meters per second. So when close to the Earth's surface, the diver should change direction by moving forward, backward, left, or right. Due to the relatively low speed to land safely, the momentum is also greatly reduced, so the diver will come out unharmed. The momentum is greatly decreased since it is dependent on the mass of the diver and the speed. Since during the fall, when gravitational potential energy was decreasing while kinetic and thermal energy was increasing, so when the diver lands, the kinetic and thermal energy will get converted back to gravitational potential energy due to the law of conservation of energy. Physics behind the early deployment of the parachute. Early deployment of the parachute can lead to a final drag force on the diver to greatly decrease speed, causing momentum to decrease as well. The diver will also reach terminal velocity earlier after opening the parachute for a period of time. There are no disadvantages to this other than having to stay in the air longer, although the diver can change the direction by moving forward, backward, left, or right, causing the air resistance to decrease, which is due to the surface area facing the direction flow to decrease. This will cause the parachute to descend at a faster speed and momentum.
A question must arise in our mind. What if parachutes fail to open? The possibility of this happening may be very small, but there is certainly a chance. As the height decreases, the kinetic energy increases. At height 0 feet, the diver will hit the earth at an extremely high velocity and will create an inelastic collision with the earth. This is lethal. This could result in the death of the diver or at the very least several broken bones. Of course, it is possible to decrease the velocity of the diver. This could be done by increasing your surface area while falling by spreading out your body into an X, or by choosing to fall carefully in a densely forested area, a swamp, dirt, or snow. The increased air resistance could decrease your speed and kinetic energy. The trees will also help slow your fall. The swamp, dirt, and snow will act like a cushion when you fall, decreasing the damage of the collision.